Assalamualaikum warahmatullahi wabarakatuh. We are from group 3. I'm going to present about hydrocarbons. I'm going to introduce to you my group member. First, my name is Fathurrahman and I'm the mentor from this group. My group members are Nur Kristina Insyirah binti Khairul Effendi, Muhammad Haziq bin Zulkifli, Aini Hafizah binti Junaidi, and lastly Nur Izzah binti Muhammad Ramli. So our group question start with the statement: the hydrocarbon with molecular formula C4H8, which is butene, consists of 5 structural isomers, namely J, K, L, M, and N. Isomer J, K, and L react with bromine in CH2Cl in the dark condition, but M and N do not. The ascending order of boiling point is arranged as J, K, and L. There are 2 isomers react with HBr to give an optical active product. So we have divided the question into 5 to make it easier for us to answer it, and the question will be answered by my group members.
Okay, for the first question, through the structure of J, K, L, M, and N, explain your answers. Okay, for the 5 structural isomers of butane are J, 2-methylpropane, second K, 1-butene, and third L, 2-butene. For the fourth structure is M, cyclobutane, and the last structure is N, methylcyclopropane. The next question is explain why J has the lowest boiling point. From the answer previously, we know that J, K, and L are alkene and can undergo electrophilic addition, while M and N are cycloalkene. J, which is 2-methylpropane, has the lowest boiling point because it is a branch alkene. We know that the smaller the molecular size, the smaller the contact surface area. The weaker the intermolecular forces, the lower boiling point. That's why J has the lowest boiling point.
The question is identify the 2 isomers that give optically active product. The isomers that can give optically active product is 1-butene and 2-butene. Both isomers will react with hydrogen bromide. This reaction is electrophilic addition, which follow Markov-Mikov rule to determine the major product. For the first isomers, the product will form is 2-bromobutene as the major product. The byproduct is bromobutene. For the second isomers, which is 2-butene, the product will form is 2-bromobutene.
The next question is write the chemical equation and reaction mechanism involved. The first step is addition of an electrophile. In this reaction, H plus is an electrophile that comes from HBr. 1-butene will react with HBr. H is more delta positive and Br is more delta negative. Double bond in 1-butene is nucleophilic site. The electron in HBr bond will be attracted to Br. The nucleophilic site will be attacked by the electrophile, which is H plus. We will get carbocation. The bond breaking is slow rate of reaction. The second step is formation of product from carbocation. In this step, Br minus become nucleophile. Br minus will be attacked by the C plus. The product form is 2-bromobutane. New bond formed in fast rate of reaction.
Okay, my name is Muhammad Haziq bin Zulkifli. Okay, here is question. Give a chemical test other than bromine in CH2Cl in the dark to distinguish between J and M. Write the chemical question and state the observation involved. Okay, in this question we use the Bayes test. Bubble of each gas through K manifold, OH minus and dilute. Okay, first we use with cyclobutane, which is M structure. Okay, there will be no color change when test with cyclobutane because cyclobutane is alkane that doesn't have double bond. Okay, the Bayes test show positive result if the compound used have double bond. Okay, the second one we use J structure, which is 2-methylpropene. Okay, when test with 2-methylpropene, the purple color turns to colorless or decolorized and brown precipitate of MnO2 is formed. Okay, here is another questions. Write the chemical equation and state the observation involved. Okay, right here we have J structure, which is 2-methylpropene react with KMNO4, which is purple solution, to form a compound which is 2-methyl propan 1,2-diol and MnO2, which is brown precipitate. So the observation here is purple color turns to colorless and brown precipitate is formed, which is MnO2. Okay, write the chemical equation and state the observation involved. Right here we have cyclobutane, which is alkane, and react with KMNO4, which is purple solution. And if we look at here, there is no reaction because cyclobutane doesn't have double bond. Like I said before, the Bayes test show positive result if there is double bond in the compound that we use. And the observation here is there is no change occur. Okay, draw the structures of the isomer of C4H8, which is butene, which shows geometrical isomerism, also known as cis-trans isomerism. Okay, the first one we have cis-2-butene. Okay, why cis? Because we have here one alkyl group attached to one carbon, this carbon, and another alkyl group attached to this carbon, and both alkyl group are being on the same side, so the name will become cis 2 butene. Okay, the second one we have trans. Why trans? Because here we have one alkyl group on the opposite side and another alkyl group on the opposite side. So when both alkyl group are being on the opposite side, we call it as trans 2 butene in this question. So
Next is the iotization. So the functional group presented is hydrocarbons, and one of the examples for hydrocarbons is the olive plant. For the related Quranic verse, we have decided to choose the verse 20 from Surah Al-Mu'minun. أعوذ بالله من الشيطان الرجيم وشجرة تخرج من طور سيناء تنبت بالدهن وصبغ للآكلين. The translation is, and we brought forth a tree issuing from Mount Sinai which produces oil and food, such as olives, for those who eat. Now, let's dig more deeply information about the olive plant. Firstly is pyrene. Pyrene is one of the components that can be found in the olive plant. Pyrene is a polycyclic aromatic hydrocarbon which consists of 4 fused benzene rings which result in flat aromatic system. The chemical formula for pyrene is C16H10. Next is the composition of the plant. A tablespoon of standard olive oil contains 119 calories, 13.5 gram of total fat, 0.08 milligram of iron, 1.94 mg of vitamin E, and 8.13 microgram of vitamin K. Lastly is the benefits of the olive plant. One thing to remember is that all parts of the olive plant is very useful towards the living thing. Firstly, the fruits of the olive plant can be eaten or used to produce olive oil. Next, the leaves of the olive plant are used for medication purpose. And lastly, the wood of the olive plant is very useful for carpentry work. Therefore, from verse 20 Surah Al-Mu'minun, we know about the greatness of Allah by creating the olive plant that is very useful for us humans.